Hello, everyone. Thank you for joining the Hindsight Take 30 session. Today's topic is Snowflake as a data wrangling sandbox. I am Neerav Walia, engagement leader with the information management practice. So on the agenda, we'll quickly talk about our Hindsight background. We'll touch upon the Snowflake architecture, some of the current problems that the customers see and how Snowflake offers a solution for those. We'll talk about the Snowflake features, and then the agile development features which are related to the sandbox that's today's topic. And then we have a Q&A. So feel free to ask questions on the chat. You might be muted through the session, but in the end, we'll open up for questions if you'd like to ask. And there is a quick poll in the middle, wouldn't take more than a few seconds so to get a sense of the audience today. So these are some of the planned sessions over the next 6 weeks. One of the topics is the one we're doing today. So these are some very nice sessions, some informative ones. So if you feel, I encourage you guys to join, if not all, most of them. Talks of various topics and various other, like data catalog, Redshift, data strategy, data lakes. So please join these as well. So let's talk about Ironside, right? So Ironside is a 20-plus-year-old data analytics consulting firm, and we help our clients use data to make better decisions about their business. And we generally take this approach of talking of the business outcomes and before a technical solution. That's the approach we always take. And this is a holistic view of the various services and the capabilities that Ironside offers. So we do advisory services a lot with data analytics, strategy, roadmap. We get health check assessments. We have a dedicated managed services service, which can help you on the platform side. And then the governance service as well. So governance, MDM, single view, we can help on all of those as well. And then the design, deploy, and build. This is related to the architecture, so we can help with data architecture, data warehouse design, visualizations, dashboarding, reporting, data science, machine learning. We can help with all of that. We can also help with some of the deploys if you need upgrades, migrations from on-prem to cloud, any of those services as well. So we have a quick poll here to get a sense of the audience today, like how familiar you are with Snowflake. So please select your options. And then, so while this goes on, I do want to mention, so today we're talking of Snowflake, but there are other partnerships that we have, whether it is with AWS, precisely, which used to be Whitney Bose before, Tableau, Data Robot, Microsoft. We work with all of these. So if you have any questions, if you want specific sessions, we can help arrange that. You can send us questions, or we can have one-on-one sessions too. So that's definitely doable. And some of those are covered in some of the other sessions we have planned, which I'll list up towards the end of this presentation. All right, so we do have the results here, and it looks like very familiar. It's 20%, so which is good to know. People have that in production. 40% are actively evaluating Snowflake POCs. 20% are exploring technology. Snowflake is one of them. Okay, and then about 20% are just beginning to learn about it. So that's good. That's a good mix for today's call. So great. Right. So oops, my screen is. Oh, sorry about that. Yeah, so this is some of the partners I was talking about earlier while you're on the poll, so we can help with any of these, Trifecta, Elation, Matillion. So feel free to reach out if you have any questions on this. So let's get into it, right? What is Snowflake? So Snowflake is a modern data platform built for any cloud. So Snowflake has a common and interchangeable code behind the scenes that enables you to run this on AWS, Azure, GCP, the cloud of your choice. And it has been designed ground up, so it's not a on-prem system before and then converted to cloud. It was designed for the cloud. It has a patented unique architecture, and one of the strongest suits I believe is it decouples storage and compute. So you can scale your compute irrespective of storage or vice versa. It is a SQL database behind the scenes. It is columnar in nature, and it supports both structured and semi-structured data. In terms of security, it was always designed with security in mind. So it supports multi-factor authentication or federated authentication if you like that. Data encryption is data is always encrypted end-to-end. And it offers role-based access control. So you can define granular privileges for your objects and the actions you can take on the objects. and assigned to the user. So that's the model it takes. Easily and securely share governed data. So that's one of the strong capability of Snowflake. We'll touch about that in a subsequent slide. So you can share your governed data within your organization, and if you wish, outside too. A pay-as-you-go model, so you pay for what you use, and you again pay separately for compute and storage based on your usage. And last but not the least, simplicity. It's very simple to use. You just sign up, start using it. It has a web interface and other ways you can connect to it as well. So architecture, right? So at a very high level, it has three layers, as we call it: the services, the compute, and the storage. So you will hear the word virtual warehouses quite a lot interchangeably through this presentation, and whenever anybody talks Snowflake, that basically means compute. So as you see here, the centralized storage, that's the heart. Everything's in one common location in Snowflake, and on top of that is the compute or the warehouses. So you could have different warehouses for ad hoc analytics or a development team, or for data loading or BI. They all talk to the same common data set underneath. And at the top is the cloud services, which is basically brain, as they call it. It manages the optimizations, the management, transaction control, security, metadata, everything is managed through that. So these are the three main layers as part of the architecture. And Snowflake calls the architecture as multi-clustered shared data. And it offers instant automatic scalability and elasticity. So current problems, right? So this is what we hear a lot when we talk to our customers, like they have siloed and diverse data. So they have structured data, semi-structured data, but they cannot ingest it easily. They cannot house that together. And it's a tough time for them to even report them or even share them. Scale and speed performance issues, right? It's difficult to scale up, scale out, or queries begin to run slower as more data comes in. Ingestion is tough. And then resource contention, right? So if there are multiple people trying to get to the same object or the same table in your database, or you're trying to write while somebody's trying to read, all of these come into issues that cause resource contention. Complexity, costly infrastructure, right? So in this case, you have to identify your software, hardware, get it installed. More often than not, you end up over provisioning, and that means you're paying for something you may not be using, and it's tough to kind of manage that. It also means there is lots of maintenance and tuning that you have to do to keep your system performant. And at the same time, likely you might have to learn some other languages because it may not necessarily be SQL. And then last is slow and limited decision making. So as your warehouse or a data lake, it gets more adoption, more users begin to come in, and then it could lead to performance issues. It's tough to have things return back to you quickly as part of your query. And it's also difficult to optimize revenue and cost because you're already committed to some of it. It's tough to change the architecture and hardware and stuff. So these are the common problems we hear about when you talk to customers. So how does Snowflake help with that, right? So we talked about the architecture is a centralized storage. So all data, whether structured and semi-structured, can live in the same database and the same table if you wish. And it supports semi-structured data out of the box. So that's one very strong feature. Then this can be a single source of truth rather than having data siloed in different data stores. It has the ability of securely sharing your data with your partners, once again, within your Snowflake account or outside. Scalability, right? Unlimited and automatic scale and speed. So it separates storage and compute, so you could scale them independently of each other. Based on your workloads, you could define different warehouses or different computes, so there is no resource contention. So your ETL team uses a warehouse versus your BI team uses another warehouse. And then it automatically handles spikes because it offers auto scaling. We'll touch upon that in a subsequent slide. So you don't have to worry about, oh, it's Monday 9 a.m., there are 100 people sending 500 queries, my system is becoming slower. Snowflake takes care of that. Next is Snowflake is a software as a service, right? So there's nothing on the infrastructure side that you need to do. You just sign up, you load your data, start running your queries, and Snowflake takes care of it. There is zero management in terms of that. There is minimal maintenance you have to do. It's generally optimized out of the box. It's fast time to value and pay as you use. And more importantly, it is completely SQL. So there is no learning curve. Your analysts can continue to write SQL the way you used to do before, and it will work perfectly fine with Snowflake. And last is the ability to scale that leads to, so as your adoption grows, more users come in, and that would lead to concurrency issues as well. Snowflake handles that using the auto scaling feature that it has. It enables fresh and complete data. We'll touch upon that in a subsequent slide, but this is data sharing. And then optimize revenue and costs. So For example, if you have multiple warehouses and ETL warehouse is used just 2 hours in the night, you would simply configure it to shut down automatically. So you could say, if there is no activity for 10 minutes, shut it down. So you're not paying for that compute. And Snowflake is smart enough, as soon as a query comes in, it will resume your warehouse. So there is no manual intervention. So that helps you save cost as well. So some of the features of Snowflake, right? So Snowflake offers 3 dimensions of scaling: scale across. That basically means workload segmentation. I touched upon this earlier. You could have various warehouses based on your workloads or your needs. One for ATL team, one BI, maybe for a data science team. Or you could also do this by your business functions. You could have one for your finance team, one for a sales team. Scale up, scale down. That means you're adding servers to your cluster. And scale out and scale in, meaning you're adding more clusters. A native support for semi-structured data out of the box. So if you have JSON data, for example, you can simply load it to a table in Snowflake. So Snowflake does this by way of a proprietary data type called variant. You can just load the data in. And then if you wish, you could parse that out. It offers functions like flattening it out into relational tables, into rows and columns, or you could just query it off this table using those functions as well. Caches, so Snowflake uses caches very smartly, not only for performance, but also for cost savings. So if your query is going to be using any of these cache, Snowflake decides the query, the result set's already available to you. You may have run the same query before. It's going to use the cache, and there is no compute cost for you because it's already saved in the cache. So it helps you on that front. Agile development, so we'll touch upon these in a couple of slides. Time travel and zero clone copy. Stored procedure in UDF. So Snowflake supports stored procedures. The only difference being these are JavaScript based. These are not SQL based. So difference being you need to kind of instantiate an object and then have methods in your JavaScript which call and execute SQL. But you can still execute your SQLs as is. It's supposed dynamic SQL. It's supposed a control flow as you would have. Only thing is a JavaScript object versus a SQL object. And then data sharing and data exchange. So one producer, multiple customers, right? So the way Snowflake offers this is you have a data in one table, for example, one database in Snowflake, and then you want to share it across different teams in your organization. So currently, if you have to do that, you end up maybe have to be FTPing the data, or there is a lag waiting for people to update that. But here, as soon as the producer updates the data, the consumers are able to see it. And this is done through secure views behind the scenes. And in terms of costing, there is no cost for the consumers. It's just compute cost. Data stored once, and there's only one-time storage cost. There's no data movement per se. And this is one way you could also monetize your data in a data exchange. You could put your data out there and then give access to people outside to consume their data. That way, you have the ability to monetize your data as well, like third-party data, if you will.
Nirav, before we go to the next slide, we have a couple questions.
Okay.
So the first is there's a couple different ways to scale up, down, across, out. What are the drivers? When do you use each one of those?
Okay, great question. So scale up, it basically means, as I said, you add more nodes to a cluster. So the use case for this would be if you have high volumes of data or you have very complex queries which need a lot of computing power, you basically use this. So this means you're resizing your warehouse. So Snowflake comes from different sizes, from extra small to 4XL. Every time you change the size, it basically doubles the number of servers. So this is when you scale up and scale down if you need to reduce it beyond a point in time. And then scale out is related to concurrency. So like you have lots of folks sending in queries lots of time, and that leads to queuing of your queries. In that case, you basically add a cluster. So it distributes the load across multiple clusters. And this can be done automatically. There is no manual intervention. So this is called auto scaling. So and this is applicable to enterprise edition and above in Snowflake. You define a minimum and a maximum cluster, say 1 to 4. And then Snowflake is smart enough to understand it. If the queries are going to be queued, it will add a cluster, spin up a cluster. And then when it sees the queries are going down, it will actually spin it down too. So you don't keep paying for that compute cost.
Okay, and then the second question, sorry if you're done, is there any downtime or impact when you do that kind of scaling?
That's a great question. So this is non-disruptive. So the queries that are running at that point in time when you decide to resize, they will execute on the resources that are already defined at that time, and future queries will begin to use the new resources. So there is no disruption. It doesn't impact. Is that all? Okay, great. Okay, so we move on to time travel, right? So So you can think of time travel as automated backups, right? So it's basically previous versions of the data that's automatically retained. And you as a customer can define the window. So it goes from 1 to 90 days. And once again, a disclaimer, this is available for enterprise edition and above. The standard edition does not support this. So in this case, you say your data is retained over a period of time that you define. So in that, you can access that via SQL extension that Snowflake offers. So it simply says select data at or before a point in time, or you could say an offset, or you could also say before my query executed on that. So this feature enables another feature called cloning, which in a way, we will talk about it in the next slide, that relates to the sandbox aspect I want to talk today. And the last one is undrop, right? So this is a great feature too. Because of this time travel feature, you can use it. So it's not uncommon that when we in an application try to update some data, we update the wrong data, or we accidentally delete the data. I've seen tables being dropped in production, right? So then what do? You have to go to your DBA team, you get to get IT teams involved, and then there's a process to get the data back and all the other aspects that go with it. But with Snowflake, you simply say undrop. And this can be done at a database level, and also in the time travel, database level, schema level, or the table level. So you can simply get it back. So think of this gives you protection against your corruption or user errors, right? And that comes inbuilt once you have this time travel defined. So this is I just want to quick snap how easy it is to do this, right? So in the first one, you're creating a table as you would create a table in any database. You're not defining anything here, so it's a default 1 day. So it restores a copy of a data for a day. And the second one, you're setting the parameter which can be used data retention time in days to 90 days. So this is a max we can do. You can actually change this if you need to, anywhere between 90 using an alter statement. You can actually disable too as well. And there are times when you want to disable it. For example, in your dev database, you actually don't need this title, right? Because there is a storage cost. The longer and more data you save, backup copies are retained, you are paying a cost for it, the storage cost. So in development, maybe you don't do this at all, right? You just set it to 0. But in your higher environments like UAT and production, you certainly want to do this because this gives you the protection against any issues that happen. And then how do you retrieve this data, right? So simple, as I said before, you could do it using a timestamp saying, give me my data from this table at this point in time. Or offset is defined in seconds. So you say, give me before my data 5 minutes ahead, or rather before current time. The last is query ID. So if you know the query ID which kind of messed up our data, you can get the query ID from the web interface or from Snowflake information schema. You just say, give me the data before I executed the query. So you can you can restore it as well if need be. So this is very easy to do. And the reason Snowflake is able to do this actually is again because of the architecture. So behind the scenes, all the data is stored in micro partitions, which is the proprietary format Snowflake uses, and they are immutable. Right? Anytime you write a data, it writes to micro partition, it cannot be changed. So it always has a copy, and then if you make a change, a new micro partition is created. So once you define your retention period, it always has a set of old data for you to bring back to life if you need. Zero clone copies. So this is instant data cloning, right? So you could do this at a database level, schema, table level, and more importantly, this is only metadata driven. So your data is not copied. And that means the data is not moved, and that means you're not paying for it. It is just stored once. So there is no cost to create clones and to use them as far as you don't modify the data. You do have the ability to modify the data. You could write insert update queries if you want on these, like any other data. In that case, what happens is modified data is written into new blocks or micro partitions, and you will begin to pay cost for that. So that's something we need to keep in mind. As far as you're just reading from these sets, you're not paying anything. But if you begin to modify, which you can, there is a cost. And if you modify the data in the clone, it does not affect your underlying. So if, for example, you took a clone to production to test, it doesn't go back and touch your production data. It's just the clone data that's modified. And you can always take a clone off a clone. That's also possible. There is no cost. So you could have one clone, say, for your data science team, or one clone for your other analysts, and they could use our Sandbox. They could do the testing exploration on that if they need, without impacting the original production database. And as we have seen as application development life cycles, we move through environments. More often than not, it's tough for us to get a copy of production quality data into our environments. That means bugs easy to get through to production because we never saw such data before. So right now, you can just, using this feature, just create a test DB or a QA DB or UA, and people can do the testing there before you actually move your code to production. So that's a great feature as well that can be used. And you have the ability to move some tables from here or modify data to production if you choose to. And then, so how do you do that, right? It's a simple SQL statement. You say create or replace database. In this case, we're creating a test database from a production database. And you can choose whether you want to do it based on an offset timing or a point in time. And as I said before, you could take multiple copies. You can clone off a clone, or you can take multiple clones of the same data set as well. So based on a use case, this can be done, and you can get as many sandboxes as you want. So yeah, and the last slide is, these are the upcoming sessions. Top ones be done with it. These are Tuesdays, we do the data science team. Wednesdays, today's team, that's data advisors, and the Thursdays, BI team. So I encourage you guys to sign up, look at these, and come and join us for any of the sessions that interest you. So with that, I will open up for Q&A.
All right. The first question we have is there any feature to mask data when you copy production data into dev for security or compliance or other reasons?
There are standard functions built in that you can use, but generally there's something that we'll have to do as a step we have to plan as part of the design when you talk about data masking.
Okay. Next question. Hold on one sec. How are JavaScript store procedures different from SQL store procedures?
Oh, great question. So the main difference being is you have to instantiate a Java object, and then you call the methods to execute a SQL. So for example, so this is something that this needs to be taken into account when you do migrations from your, say, on-prem to a cloud. And if your ELT and ETL is using a lot of stored procedures, this is something we have to plan an effort around because we have to change them to JavaScript. So for example, it's about dynamic SQL, so you can still do that. Just that you have to instantiate a Java object and then call a method, say execute my SQL. So there is slight syntax, those syntaxes that need to be learned, and it supports those. So it's a JavaScript-based object versus the SQL object, main difference.
Okay, thank you. What is the difference between data sharing and cloning?
That's a good question too. So all the data sharing and data cloning are like two separate independent features. Generally don't compare, but yeah. So data sharing is mainly meant for sharing data, as I said earlier. So you have one producer and that puts your data in a Snowflake table or a database, and then you can share it to multiple users. So in this case, the cost for that storage is for a producer and not for the consumer. The readers can read the data, they pay compute costs, but there is no storage cost. Whereas for cloning, there is no storage cost, as you said, as far as you do not modify the data. There is no cost for consuming data. In terms of refresh options, right? So for sharing, as far as the producer updates the data, it is generally up to date for the consumers. There is nothing there to refresh the data, or there is no movement. Whereas on the cloning side, the data is always point in time, right? So it's never updated. So if you create a clone, say, for the data from a week ago, it stays that way. So it's not updated. And then in terms of boundary, right? Like what was the scope of this data? So when you want to share a data, you can share your data outside of your Snowflake account. You can give access to reader accounts, as they call it, and they can still come and use your data. So that kind of helps you monetize your data if you need to. Whereas on cloning, the scope is within Snowflake account. So you can share, you can create clones, and that can be used by other users in your Snowflake account. And yeah, I think these are the three main points that to consider on between data sharing and cloning.
Okay, makes sense. The next question we have is, what methods can you use to connect to Snowflake?
Okay, so there are multiple ways you can do that. So it offers many tools and interfaces. So Snowflake has a web UI, which is great. If you want to do a GUI-based approach, then it offers a command line client. It's called SnowSQL, so you can use that as part of application development. You can use that. Then it offers some specific connectors as well, like you can have one for a Spark or Node.js or any of those interfaces as well. And it definitely supports the native connectivity using ODBC, JDBC, the standards that we use to connect to any database today. So all of that is supported as well. So multiple ways, and if there's any real-time need, there is NoSQL as well. So.
Okay. The next question is, you talked a lot about the storage costs with some of these features. How do the storage costs compare to compute costs in general in Snowflake?
Okay, so the storage costs are defined by, it's basically per terabyte cost. The underlying platform and the region generally impacts that cost a little bit between the vendors, like between AWS or Azure, for example. So that's given by per terabyte. You can buy storage as prepay, or you can do on demand. On demand, of course, it's slightly expensive than prepay. In terms of compute, it is driven by per hour usage of the servers, and it is billed at every second. So, for example, if you have an extra small warehouse, that's pretty much one server or one node, you're paying the cost for that. But if you have a small, which is twice the number of costs, then your credits, they call it credits in Snowflake, so your credits double. But one thing to understand is, generally speaking, when you upgrade your size from, say, from extra small to small or any other size upfront, it kind of linearly scales with performance as well. So for example, if you're using 10 minutes on an extra small, you're paying 10 minutes worth of credit on that one server. But on the small, you might likely query will run in 5 minutes. So you're now paying 5 minutes into 2 servers. Your cost might still be in the same ballpark, but you're getting much better performance. So this is something that you can evaluate, and it's easy to change. Size is very easy to change, so it's not something you can get or you should get right out of the box on day one. This, based on your use cases, based on how your data grows, you can keep defining it, and that drives your cost. So these are the two ways, difference between storage and compute cost. And I just add to that, so on the web interface, there, if you're an account admin, which is the highest privilege, there is a usage and billing section, which actually tells you exactly your costs, when it was used, what warehouse was the user, and also storage. So all that information can be collected from there. Or if you want an interface, there is an information schema that comes along with every database. And there are tables and views in there. You could use that as well to look at the cost that you have. And in terms, like, I'll probably add one more thing to this. So, like, how do you manage, right? Like, how do you control costs? Right? Let's say you have 5 warehouses, and then you want to limit each warehouse or each function to use only X amount of credits, so you don't run out of credits quickly. So there are features, it's called resource monitors. So you can set them up, and those can be set at account level. So that every warehouse in the account cannot go beyond a specified threshold that you define. Saying, for example, you can only use 500 credits per month. Whereas for another function or another department, you might say you can use only 200 credits per month. So then you can define what happens if they exceed or if they're nearing that. So you could just suspend, for example. So if my team, which was allocated 500 credits per month, I'm hitting that, I can say 80% threshold, I'm at 400, and notification goes out. So I can begin to see why, and then either I have to figure out how I'm going to control it. The other option is you can immediately suspend, right? So that's your choice. The warehouse just does nothing. It just resets at the end of next month. So these way you can control your cost across your various accounts, your various warehouses that you have, so that you're not surprised at the end of the month. And this is something we strongly recommend, because costs could shoot up if it's not planned for.
Okay, I think actually that was the last question, and I think we're just about at 11:30.
Okay. So great, then thank you everyone. And if you have any more questions, feel free to reach out. We definitely will try to answer as many as we can. If you need or interested in one-on-one sessions, we can definitely do that as well. So thank you all for the time today, and look forward on the other sessions.